Here in our first example, we have the idea of a try-catch block. So remember, the idea here is, and I'm not trying to make this any more or less complicated than it has to be, we are going to try something. If that something throws an exception, the catch is there immediately thereafter to have to try and deal with it. So we've got our ages-old example here of the divide by zero error. Now, again, this is something that you have been taking care of with an if else or with a while block in all of your code to date. The additional benefit here to actually using error resolution in the form of throwing an exception is that down the road, when things are not as evident as it's going to be in the case of a divide by zero, where there are going to be faults outside of things that can be easily rectified by a user who is still staring at your solution. So think about things like a timeout issue, where one method is relying on another to be done doing what it's doing in a certain amount of time. And, if a file is open and unavailable, or if a process hasn't returned with a batch of new objects, what is that next function down supposed to do? Puke. And that's not necessarily what you want to see. We want to be able to resolve what that issue is. So instead of having your program puke and not give you any indication as to what the issue is, what we want to rely on an exception to do is, at the very least, and that's what we're going to see here, is the very least. We've got one more example right after this. At the very least, we want to be able to, put a label on what it is that the exception was. So we see that here on lines 18 through 25. So the try here is going to divide two numbers, number 1 by number 2, both of which are integers. We can see that here. And here in our divide method, we actually see throws exception string. So what is happening here inside of our divide function is, if denominator equals 0, you'll go here and you will throw exception, as opposed to returning. Now, just a little side sortie here. Notice we cannot rely on integer division. So here we are casting our result of integer division as a double for the return, which is smart, because remember, if we don't do this, we're going to get, 9 divided by 2 equals 4, which is not correct. So in the condition that, I'm trying not to use the word, in the case that our denominator equals 0, throw an exception. And that exception to be thrown is this exception string. So what's going to happen is, I'm going to go ahead and run this and we'll see this. So I'm going to say two numbers, 10 and 0, cannot divide by 0. This string was the result of encountering an exception, right? Because we have made our string exception string right here, and then we throw this exception. What this is going to cause the program to do is skip the return static cast double. It's going to come here to line 23 to my next most available catch block. So the thing, and I apologize for being so general here, the result here is that my catch is got to be something. So we can throw a string over here, and the result of that string we can put in our output. We could throw an object over here so that we could, or a reference to an object would be better. We can throw the reference to the object over here so that we can see what it was that triggered, or the result of the thing that triggered our error was. There's a bunch of different ways to do this. This particular methodology here is just so that we can, and you can see it up above, vomit a cannot divide by zero error. But you will notice that the exception is handled. If we did not have this try catch block, we would have terminated the program, and line number 28 here would not have had an opportunity to run. It simply would have puked out, and we would see, our red less than, or greater than rather, operator here. I still reverse everything as though I was in a classroom. It's a problem. So this is the result of that error being handled. Even though we did not necessarily recover from our error, we at least were able to exit the program in a way that also gives us an opportunity to find out what the issue was. We can look at the resulting output and say, error cannot divide by zero, and at least reverse engineer a solution for the next time based on that error.